Go.
Hey!
Hello, Mr. Aaron, Mr. Ryan. How are you today?
Good.
Okay, so remember a few days ago we talked about a two-sum, yeah? So it's given an array 1, 2, 5, 3, 2, 7, and given a target like 5. And then can you find the index?
2, 3.
2, 3, yes, all 3, 2, you know, it just doesn't matter, okay? The first one or anyone, yeah. So, how are we doing this? Remember? The brute force and
Yeah, brute force.
brute force, but
Brute force takes a long time.
what's the time complexity for the brute forcing?
1. And I think something square.
Yeah, look, every time you check, you iterate these n numbers, and then for the second number you iterate n, right? Yeah, all right.
Yeah.
Okay, so we can use the which data structure we can use to speed it up?
Notebook.
Notebook, yes, because when we visit once, we remember it on the notebook, and then we check if the target minus the current number, if it's in the notebook, right? Do you understand? Yeah.
Are we gonna talk about something like 3-sum?
Oh, good point. Yeah, but maybe not today, but maybe later, or 4-sum, 5-sum, right? So today we'll talk about if the array is sorted, what happens? So if the array is
It'll be
sorted,
much easier.
really? Okay, let's say 1, 2, 4,
You
7.
need commas.
Okay, 1, 2, 3, 4,
1,000.
8. Let's find if there are 5. So how do if this array is sorted, it's all 2, 3. Yeah. How do you get it? How do you can you come up with the fast algorithm to do it, or in ON time? Can you do it in ON time? Remember we talked about. I give you a hint. How about if I start from here and here? 1 plus. Yeah. Okay.
Okay. So if you just add them up together,
And then
if
bigger.
it adds up to bigger than the target,
Yeah.
this pointer goes here.
Yeah. Okay. Still bigger, yeah, and then go here, yeah, and you find it. If it's smaller, you move it, right?
Yeah.
That's time complexity, okay, yeah.
Yeah.
Does it make sense?
Yeah.
So this requires the array to be sorted, yeah. All right.
Yeah.
Okay, can we write this quickly? Define 2-sum
2-sum.
sorted, okay. But it
3-sum.
nums. Don't do this. Target, okay. Column, okay. Look. I(j) equals 0, length t minus 1, okay? So I and j pointing to both ends, alright? Yeah?
Yeah.
While I smaller than j, right? Come on, yeah? Alright?
Well,
Yeah? If num
It's smaller than
I
target.
plus num j equals target.
We
Let's
return
actually
it.
it's nums, not t's, okay? Then we return, we know
Yeah.
it's there, return this I or j, or we just return true if to mean that we find it, okay? If nums I plus nums j smaller than t, what happened? Can you tell me? If I plus nums j smaller than t,
We move I.
I what?
Add equals 1.
Yeah, where that? And
Yeah!
else what?
J minus equals 1. Yeah!
Okay, and then return here what? We are returning true if we found it. We here returning what? If we can't find it, return what?
Fast.
False. Return false. Get it? Yeah? Does it make sense? Yeah? Okay, now another look, okay? So this is
Why?
ON time. And what's the space complexity?
I think ON.
Where are we using the space here? Which do you think is ON space? Are there any space we need to use?
Nope.
And what's it?
O1.
O1 constant, okay. O1 constant.
O1 constant.
And how
I
about
should
look?
look at that.
Yeah, that's okay. 1, 2, 3,
4.
5, 7, 9. Okay, so
Oh,
let's look for number 5. And if we can How?
T3.
Yeah, I know. We can use the 2 pointer, yeah?
Yeah, I
Just
know.
like that, moving towards until they meet each other. How about if we use another approach, like because this array is already sorted. Let's just check this number. Try the first number like 1, and let's find if the rest of the numbers have the 4, because 5 minus 1 is 4. Yeah, all right.
Yeah.
And if I try 2, if there are 3 in this part, right? Alright?
Yeah.
So basically we can try the first number, 1, 2, 3, 4, 5. And then we try the number next to it, right to it. Because it's already sorted and we're looking for the number which is 5 minus 1, minus that number. So what's this? Finding a number in a sorted array. What it is? The time complexity. Finding the number in a sorted array. What's the time complexity of finding a number?
Worst case n.
Sorry?
I think n or 1.
Finding it in a sorted array. Finding a number. You always check in the how, right?
Log n.
Log n, okay. And then but the first number is n, right?
Yeah.
So it needs n times log n. Alright?
Yeah.
Okay, so let's do it.
Let's do it.
Yeah, so look, first of all, I need to define the binary search, yeah? Define binary search, okay? BS. And then let's do I for the left, okay? Maybe left and right, okay? And then we're looking for the number T. Right? Yes? Yeah?
Yeah.
Okay, so how are we doing it? Suppose we know the numbers here. While left smaller equals right, okay? What's the middle?
The middle is
If we're left and right, what's the middle?
left and right divided by 2.
Okay, divided, we use the double divide, okay? Then look, if nums middle equals target, we return, let's say we return true, okay? Right?
Yeah.
If nums mid smaller than t, what should we do? If t is bigger than a half, so look, this is the middle. If the number we are looking for is on this side, so what should we do? Huh?
We should.
T is here because this is middle, this is L, this is R, and then this is middle. And then the number we are looking for is T.
We cut it in half again.
Yeah, but so we need to move left to mid or R to the mid.
Left to
Left
mid,
equal.
add 1.
Yeah.
Eh.
And else what? If it's
Else.
smaller. If it's smaller. If it's in this half, what should we do? If it is in this half.
Right equals mid minus 1.
Okay, and return what here?
Return.
We are returning
T.
true. Returning true when we found it, and here.
False.
Yes, returning false. This complexity is O1.
Again.
Yeah, well done. What's the space complexity for this one? O something here. O what? Do we need to O what? Do we need a space?
1.
Yeah, O1. Okay.
Yeah.
Okay, so
My
remember this
favorite.
B as left to right. Okay, that's fine. B as left to right T. Okay, remember this function, yeah? And then look. So what should we just do? Look, for I in range length numbers, yeah? The first number, yeah? First number is I. The index is I, right? Yeah, Eric?
Yeah.
And the number we are looking for is, let's say A equals T minus nums I, right? Yeah? This is the number we're looking for. Look, Eric.
Yeah.
Alright? Yeah?
Yeah.
Because we want to add it to T, and then we know we are now numbers I, right? And the numbers we're looking for is A, right?
Yeah.
Then if BS, what's the left? What should I do the left? Left, right will be length num minus 1, right? And then A, return true, right? Does it make sense? So can you fill in here? Return what? Here, return what?
Return true.
We are returning true in false here. Okay, and here, remember this is the left, this is the right. So what's the left value? I should binary search. So look, we are fixing this. This is I. Yeah? We are currently at here, and we want to find the value here, the binary search here, because the entire array is sorted. Yeah, we try this first number 1, 2, and then we want to find the, for example, 5 minus 2. Find the number 3 in the rest. So what should I put here? The left. What does it equal?
Left.
What's left?
I add 1.
Yeah, that's what I'm looking for. Come on. Yeah. And length nums minus 1 is the last element. Yeah. Got it? All right. So look, this is on. Yeah. This loop. Yeah. All right.
Yeah.
And this is binary search in the rest, so it'll be O log n. Normally, actually, look, because every time, if you're not putting I minus 1, if you put a 0, it will still work, right? It will still work because you're binary search in the whole array, right? Yeah, but there are some repeated range, because look, I already tried 1, 2, 3, right? I don't need to search for the elements before me, right? Because I already searched it, right? Does it make sense?
Yeah.
So you're narrowing down, you're narrowing the search space for the binary search. Eric, does it make sense? So you'll be quicker. But actually the time complexity is still O n log n. Actually it's O n log n. And this n is getting smaller, right, Eric? This n is getting smaller, but it still is in the same scale of this n. So it's a constant here. So we drop the constant, alright? Does it make sense? So it's still O n log n. Am I right? Look, yeah? Yeah, am I right? So can you tell me what should I put here? Okay, that's it.
What?
For I in range this and A, what's the A? What's the value we are looking for? What's A equals?
Something about I.
Because A nums I, this is current the first number, plus something equals the target number. So this is the number we are looking for. So A equals what?
T.
This is A.
Nums
T what?
minus nums I.
Yeah, come on. This is super easy, yeah? Right? And then we search it for, remember this PS function, yeah? O log n, yeah? This is O n times, log n times. So the complexity is what? O n log n. What's the stakes on complexity?
1.
Yeah, well done.
Yeah. My favorite.
Your favorite, but sometimes it's not true, yeah? You're just guessing. Okay? That's it for today. So does it make sense today? Good? Say bye-bye to people.
Bye.